Now, looking at this question, you might be wondering, how can we be able to determine the total number of electrons that can be held by this sub-level, in this case, given that the angular momentum number is equal to 2. And the foundation to the factorial question comes from your understanding of quantum numbers. In this case, on our previous videos, we looked at the 4 types of quantum numbers. We looked at the n, which is the principal quantum number. We looked at the l, which is the angular momentum, which is what we are going to be focusing on for this video here. And there are other quantum numbers like the magnetic quantum number, which is ml, and the spin quantum number, which is ms. We're going to be looking at the l specifically speaking, and the l here, according to this question, says that the value is equal to 2. And this here, when we look at 2, we look at 2 as a number, but also in terms of sub-level, we look at it based on what letters. And this letters here describes the shape of this particular orbital, and the shape in here is S for the 0 number, and the S here represents that it is spherical. Then we have R1, which represents the p orbitals, and these are the lobes. And then we have R2, which are the d orbitals. And now you're wondering, how does this play a role in us determining what the total number of electrons can be contained within the d orbitals? And this here looks at what the fantastic formula that you should remember, which is the 4 bracket L plus 2. And what does this mean? This means here that we can determine the maximum number of electrons max that can be held at a specific sub level. And an example in this case is, let's say that we want to determine what the maximum number is for our s orbital. We know that s orbital is represented as L to be equal to 0. When we put this into our equation, we have our 4 times 0, which gives you 0 plus 2, which gives you 2 electrons. That is the maximum number of electrons that can be contained in that sub-level. But hey, for this type of question, because we are looking at where L is equal to 2, when we put this into this equation, what do we get? We get our 4 multiplied by 2, which gives us 8, and we add 2, and this here gives us 10 electrons. And this here is the maximum number of electrons that can be contained at this particular sub-level. And a great application of this is looking at the different parts on the periodic table, like the d block, or people call it the transition metals. They do have these d orbitals present, and that allows them to have incredible amount of electron filling and some weird pairing and unpairing of electrons. Because in here, when we look at the ml section, the ml section implies that our d orbital has 5 different orientation of these orbitals. This here shows that when we have all the orbitals completely filled, that means that we have all of them paired up and they are all in opposite direction, and this is our 5th pair. And so this here shows that we have 10 electrons in total that are present in the d orbitals. And I hope you found this really informative in terms of using this key information here, which is this particular equation, to be able to determine the maximum number of electrons that can be present or contained in a specific sub-level. Hope you found this really informative. Hit a comment down below, let me know your thought about this. By that way, we can talk to you soon. Stay smart as always, and keep on practicing.